Hello and welcome to another video. Grab your snacks because this is going to be a long one. Today we're talking about Python 3.12, which is not quite out yet. It's about to be release candidate, I believe tomorrow actually, from the time I'm recording this. But it's basically finalized from features, so I figured I would throw together the video highlighting the things that you should care about in 3.12, or well, maybe the things that I think are interesting. At a high level, I actually think Python 3.12 is not that big of a deal of a release. Most people probably won't care about the contents, but I figured I would go over the things that I think are cool. And we're actually going to start with one that's not really that important at all, but I thought it was just so funny that I had to start with it first. And that is that the calendar module is getting two new enumerations, one for day and one for month. And that's not the part that's funny here. It is a little bit weird that day is 0 indexed, starts on Monday, and month is 1 indexed, and why didn't this start on February? Anyway, that's not the weird thing. This matches up with how the calendar module treats dates in Python, so it totally makes sense. What's weird to me is in Python 3.11, and actually really every version of Python, we'll look at this in a second, the calendar module already sort of has some of these constants. So if we look at calendar.january, you'll see that it exists and it's 1. February also exists and it's 2. But March does not. There's no March. There's none of the other months either. It is just January and just February. And apparently it has always been this way. In fact, the original commit of Python here, initial revision, maybe this is the original revision of 2. No, this is 1990. Yeah, this is the absolute beginning. Introduced these two constants in calendar.py. Where did they go? Yeah, right here. So it's kind of always been that way. There's never been any month after February. There are only 2 months in Python. Anyway, I thought I would start with that because I thought it was funny, but that's not really that important. Anyway, let's move on to things that actually matter. And the first one we're going to talk about is a syntax change to Python. This is that fstrings are syntactic formalization. Mumbo jumbo here. Basically, fstrings are allowed to be infinitely nested now, and they can contain backslashes. Neither of these were possible before, but you can have an fstring that has an fstring inside of it. Hooray! And in fact, oops, well, we need to be in Python 3.12, of course. Hi. It's not the most interesting example, however, oh, yeah, of course we need to set hi to a value. This is not the most interesting example, but you'll notice here that the nesting of this can contain whatever quotes you want. So single quote, etc. Previously, you had to alternate them, or alternate to triple quotes, or do all sorts of other jumping through hoops to make this work, but now they can be arbitrarily nested and they can have whatever arbitrary quotes. Basically, inside of these curly braces is an entirely new expression that doesn't have any escaping rules to anything outside of it. Another thing that comes with this is you can also have new lines inside of these. So this is now a valid expression. This curly brace is a single f-string replacement part, and this can contain it can contain code, it can contain comments. You basically have the full language at your disposal inside of these curly braces. It also means that you can use backslashes in here. Before, backslashes were forbidden inside of the little placeholder part, mostly because it was hard to parse. But now the full parser runs on the inner parts here. This has some some fun side effects. For me, I actually think this change is, well, it's nice in a lot of ways, like the backslash stuff, really convenient. It's also not nice in some other ways. Like, I find this really hard to read, but also text editors are going to have a problem with this. This is pretty difficult to parse, and like, there's going to be a lot of code that assumes that this is how a string looks in previous things. So there's going to be some interesting stuff that comes out of this, but I don't know. The tools will have to evolve in order to support it. Another side effect of this change is that the tokenizer, which I write a lot of linters and code formatters, so I deal with the AST level and the tokenization level a lot. The tokenizer needed to be sort of rewritten in order to handle this. And core devs actually took this chance to rewrite the public-facing tokenizer, the tokenize module in C. So if we look at typedict tokenize, go all the way down here, you'll see that there's no longer, there used to be this giant state machine in here, but now there is basically just this generate tokens from C tokenizer. And one effect of rewriting this tokenizer in C is, oops, I'm jumping ahead, is that it's much faster. I've actually written a little script here. Basically, all it does is takes all of the file names that are passed in, runs them through the tokenizer, and this is like a little macro benchmark for how tokenization works. And if we do best of this little script that I wrote that just runs something a bunch of times, we look at Python 3.11, all of the Python files. So basically, I'm going to tokenize every Python file inside the pre-commit repo. And we'll see in 3.11, it takes about 389 milliseconds at best. And you'll see 3.12 is significantly faster. The benchmarks that were reported were 60-some% in the release notes. And yeah, that's basically what we're seeing here. So the new tokenizer is written in C, and this will have a lot of really good things for linters and code formatters that are using the tokenizer. Basically, they'll get a bunch of speed up for free just because the tokenizer was rewritten. Now, one unfortunate part about this is because the tokenizer was rewritten and because it needed to handle this new fstring thing, there's some new parts to the tokenizer, and a lot of linting libraries are going to be mysteriously broken because of this. I'll give you an example. In 3.11, how this works? I think so. Maybe I have to use dev standard in. Yeah, there we go. So in 3.11, when you tokenized an fstring, there's an fstring here, you'll see that you get a single string token for the entire fstring. This was, I guess convenient at the time, but it meant that you couldn't really introspect parts of the fstring. You couldn't know that this was a separate expression. You didn't know where the placeholders were, etc. And with the formalization of the syntax, there are now separate tokens for each of the parts of an fstring. You have the fstring start, which will include the f token, whatever other modifiers, whether it's a raw f string, front string, whether it's single quoted or triple quoted strings. You'll have f string middle for any of the sort of meat of the string, not the actual evaluated parts. And then you'll have your placeholders separated by ops. And so you can see here, this is the placeholder. And if you had a full expression in here, you would have that as well. Cool part about this, actually, I wrote a code formatter called PyUpgrade, and it used to not be able to do anything inside of fstring replacement parts. It was just kind of a hard to solve problem, and I probably could have parsed it myself and then manually ran it through the AST and mumbo jumbo. But now I don't need to because it's separated out for me, so I can immediately replace these tokens inside of here. But a lot of code that's not expecting this is going to see a lot of weird stuff. One of the biggest bugs that I've seen with this is, let's say, for instance, you have a parenthesis as part of your fstring component here. Maybe, a and then parentheses around world or something like that. A variable. One problem with this is you'll see we have these fstring middle tokens, and if you're not careful with, processing over the tokenization output, you might treat this as a parenthesis. However, the only things that are parentheses will be the op token. So you got a bunch of weird stuff there. A bunch of linters will have to adjust and make that work. But in theory, it adds some cool things and also adds a bunch of work for people maintaining linters. And it's way faster. I'm really happy about it being way faster. Okay, cool. So that's fstrings. Let's talk about the next thing, which is the modules that are going away. The first one is kind of a doozy, which is the disutels module. This has historically gone back and forth between disutels, setup tools, and all sorts of different Python package building software. And the TLDR of it is disutels has been superseded / replaced by setup tools. Setup tools is, I guess, I don't want to say the most modern way to package, because it seems like Python has decided a different way to do this every day of the week, and Some of the most recent PEPs enable that or encourage that. But from like a classical packaging perspective, setup tools is like the most mature and has been around the longest. And setup tools has kind of engulfed disutils. So even though this is gone, it's not part of the standard library anymore. You can still pip install setup tools and get there. And actually, that brings me to another thing. It's a little bit out of order from my little cheat sheet, but we'll do it right here. When you make a virtual env in Python 3.12, we'll do that with this is not going to work. Well, we'll try this real quick. I'm missing the VM module, so I'm going to have all sorts of problems. Dang it. Well, you'll just have to trust me. Anyway, the VM module no longer comes with setup tools anymore. And this is because pip has formalized its isolated build setup, and that will provision setup tools in wheel if it needs to. And so the standard lib no longer needs to carry setup tools around. I can actually do this with virtualenv instead. And virtualenv has also followed that same precedence here. So you'll see that VM bin pip freeze all. You'll see that we just have pip installed. We no longer have setup tools in wheel. And so you just kind of get this very blank virtualenv. But if we do need to get to disutils, we can install setup tools and then import disutils. That's the roundabout thing that I was trying to get to. So if you do need disutils, you can still get it even though it's no longer part of the standard library. You just have to get it from setup tools now. Cool. The other module that was removed in 3.12 is the imp module. Most people shouldn't care about this. This is kind of the old import system machinery stuff. You used to use this to sort of introspect how importing worked in Python, and almost all of this, actually all of this was replaced by importlib, which was a reimplementation of the import system in Python and a way that you can plug into it directly. Imp had a bunch of constants and a bunch of helper functions, and the docs go over all of the replacements here. But most people aren't going to care about this, so it is just one of the two things that was removed. Okay, that's the removals. Next, we're going to talk about typing changes, and there are two new syntaxes, well, one syntax that is two different things, sort of. We'll talk about the syntax changes first, and then we'll talk about the other typing things after that. And those are all wrapped up in PEP 695, which talks about type parameters. I'm going to go over this very briefly, and note that my text editor is going to hate this because it has not caught up with the new syntax yet, and so it's going to highlight this all sorts of weird, but you'll just have to bear with that part. A bunch of red squigglies, but that's how things go. So there are two new things that happened here. The first is the type parameters. We'll talk about that one first. I know it says type parameter syntax here, but type aliases also got wrapped up in this. And what this is it allows generics to be specified a little bit easier than before. Before, you would do from typing import type var, and then you would assign a type var at the module, and you would have to match the variable name with this text here, and then you would say like you'd have a function which took in something, I don't know, maybe takes in t, returns list of t. Very simple function that uses generics. I've gone over generics in a previous video. There's no way I'm going to remember to link it in the description, but maybe someone will remind me in the comments and then I'll link it after that. But yeah, here's how you would do old school generics. In Python 3.12, there is now a first class parameter syntax for this. So instead of having this type var nonsense at the top, you instead have a bracketed generics here, and oops, it should actually be capital T. And yeah, here's where the syntax of my editor uses old syntax, so it doesn't know how to highlight this yet. But basically you have square brackets here. You can name as many type parameters as you need. These are scoped inside this function. So if I were to access T outside of here, it's going to be a name error. This is only inside the scope of this function. This actually introduces a special scope in in the way this is defined. So it's tu and v are only available in like this parameter list onwards, and not the decorators, but in a weird way. I might be wrong about that. I think maybe they are in the decorators. Anyway, there's a new scope. It's a little bit special. And the other part about this is, oh, we have to go back to the old syntax from typing import type var. We'll name it something else so we don't clobber. With old type vars, you would use a bound to say that something must be, this type variable must be a subclass of this thing. So all z's are some type of int. You know, maybe they're a specialized subclass of int. Int is a bad example here. You know, imagine something else here. You know, an abstract base class or something like that. You can do the same thing here by specifying a bound with a colon. This is saying that t is a type var and it is bound by it. So all t's must be integers here. And so that's basically the same syntax here. There is actually a new special thing about this annotation here. This is always a forward annotation, so you don't need to do any sort of quoting here. This can refer to things further on in your file, and it sort of follows the future annotations lookup. It's not exactly like that. There's actually some specialized code that is maybe going to make annotations magically do deferred lookup, but it's tentatively implemented for this type var syntax here. So these bounds don't need to be quoted. They can just forward annotate as much as possible. Okay, cool. So that's kind of type variables. This is implemented on functions. It's also implemented on async functions, G, T, you know, etc. And it's also implemented on classes. So you can make a class that has column T that has type variables, and it basically works the same in all of them. It is scoped. The other neat thing, and one of the reasons for making this this new syntax, is these type variables are scoped to a particular class. So even though this is T here, this is T here, and this is T here, they are all separate type variables, and they're distinct, and you can't cross-reference them. Whereas when they were at the module scope, it was a little bit ambiguous whether you could cross-reference them. Most type checkers implemented it that you can't, but there was definitely gray areas where it was a little ambiguous here. Okay, anyway, that's type vars. I don't know that this will get used very often, just because generics don't seem to get used very often, but it is there now, and it is, in theory, a nicer syntax. I actually find the new syntax really hard to read, so maybe I'll get used to it over time, but I don't know. I'm not so much of a fan of this. Okay, the other thing that got introduced in this same PEP is the type syntax. Previously, if you made a type alias, there was old school aliases, which were just an assignment at the module level. There was newer aliases where you do from typing import type alias. You would explicitly say this is a type alias, and then you could use quoted names in here instead of just types here. And these are both deprecated for the new syntax, which looks like this: type newest equals int. So there is a type statement, and yeah, this is the alias name, and this is the alias value. These type aliases can also have type variables as above. So newest with generic. So it can also have this. So this is a type alias that is generic on T. And of course, you can do the same bound stuff here, and works basically the same as the type parameters above. Now, there is one unfortunate downside to these, which is that they are incompatible with isInstance. So if we were to do our old alias here and say isInstance 5 old, this works fine, because this is really just an assignment to int. There's nothing special here, and so this is treated as the same type here. However, if we use the new type syntax here and we say isInstance 5 newest, we get an error here. There is a way to access the underlying type. I think it's underscore value. Yeah, so you could do this, but I believe it is discouraged, and kind of just an unfortunate thing here. So yeah, the new type syntax is not a drop-in replacement for the old one. So if you are swapping out your aliases, make sure that they're not actually used at runtime. Okay, cool. So that's the syntax changes. There are three other typing things that were introduced in 3.12, and we'll go over those very quickly. The first is you can use typedicts for ** quarks typing. Many people, I see this mistake all the time at work, where someone will type a ** quargs as dict stir any or something like this. And what this actually means is that each value, each named argument must be a dictionary. So this is not okay, or x equals 1, y equals 2. But what it is actually saying is that f must be dictionaries for all of these. This is the only way that you could call this legally, which is annoying. And so what people would often do is just say, well, I give up on typing this. It's just any now. It's just any now, which isn't great because sometimes you want to actually describe the shape of your keyword args, and one way to describe the shape of a dictionary is with typedict. And so they put together a PEP, and now you can type this with a typedict. Now you don't type it directly, you have to utilize unpack, which was introduced in 3.11. Class D typedict x int y stir, and so you type this as unpack D. Now, it would have been nice if they would have implemented it as they did with typevert tuples, where you could use star args here. This is not implemented yet. This syntax does not exist. They gave up on adding this syntax in the PEP because it was going to take too long to get that formalized, and so they went with this, and they may add the other syntax later. So it's a little bit ugly, but it is a way to use typedicts in this. And so now, given this syntax here, this is an allowed signature. X equals 1, y equals foo. But no other keyword arguments are allowed here. Now, I don't know why you would, well, I do know why. One reason that you might do this is if you're passing along this set of keyword arguments to some underlying function, it might be convenient to type them with a typedict. But otherwise, I would just use the named arguments directly. Not that great of a reason to do it this way. But anyway, that's the first one, typedict. The second one is the buffer type in collections ABC. This is representing binary types, so bytes, memory view, etc. Not all that interesting for most people, but it is brand new. There's also a new double under method buffer, and there's a way that types now represent themselves as buffers, and there's actually a release buffer double under method as well that I don't know why it's not called out here. Probably should be. But yeah, way to represent binary types. The last typing change is the override decorator. This one is actually kind of interesting, but I don't know that it's that useful. The idea behind override is sometimes you would implement a class hierarchy. So let's say we have a method called frob, and we implement a subclass of this. Maybe this is somewhere else in your very large work code base, and you implement your own version of frob, which we print default here. We implement our own frob here, and this prints something else. And maybe this class actually works by having a do work, and this do work calls self.frob. And this is all fine and dandy. If we run, if we make a D and call do work, this does what we expect. Why? We've correctly overridden our frob method. Everything is fine and dandy. But a refactor may come along where the base class decides, you know what, I'm going to rename this frob method to new frob. And this subclass here doesn't really know that changed. This frob method still is syntactically correct. It still type checks. It's valid. It would work. And in fact, if we run it, it still runs as well. It doesn't crash, but it no longer has the overridden behavior. And so what override is it's an explicit way to say, I am overriding this method from the base class. If the base class were to change and this method were to disappear and not have the same signature, please give me a type error in my type checker. And it's a way to basically make the type checker smarter about this type of override situation and turn this into an error. I don't know that I'll really use this. For one reason, I don't really do inheritance all that often, and that it's not that great. But I don't know. In theory, if you're an inheritance-heavy code base, this may be useful, especially if refactors are going to happen. However, if you're going to refactor this, it's probably a good idea to do this. But maybe you have a bunch of libraries and a bunch of repos, or you have thousands of files, or your IDE sucks, or who knows. But this might be useful for that. Okay, done with typing garbage, onto other things that are maybe more useful. This one is a performance change that happened in 3.12, and that is that comprehensions, list comprehensions, set comprehensions, dictionary comprehensions, not generators? Yeah, not generators maybe? I don't know. Yeah, no, not generators. Are now inlined inside of functions. This is a performance benefit. I will show you an example in 3.11 how this used to compile. I actually did a video on Python is compiled. I'll try and remember to link that in the description as well. Otherwise, you can search Anthony Wright's code Python compiled, and you'll probably get there. All right, so we're going to import the dis module. This is the disassembly module, which shows us how our functions are compiled. And we're going to make a very simple function here, I times 2 for I in range 5. This is a list comprehension, and we're just going to return it. Very simple function. If we disassemble f here, we actually get a lot of code here. You'll notice here that we get a function here for f, and we also get a special secondary function for the list comprehension. This actually implements our list comprehension here, and it is technically a separate function that's attached to the original function. So we have two functions here. And turns out calling functions in Python is a little bit expensive. It creates a new frame, there's a whole bunch of allocations, deallocations, and that is expensive. And if you can avoid function calls, generally it makes code faster if you're micronizing stuff. But this is the 3.11 version of this. In 3.12, it is a little bit different. You'll see this is actually essentially just a for loop, a for loop with list append, which is kind of cool. In 3.12, if we take that same function for dist ff x equals I times 2 for I in range 5, return x. We disassemble this same function in Python 3.12. You'll see that we only get a single function here. There's no separate list comprehension function. It's all inlined inside of f. And the way this works is actually a little bit tricky. You'll see this special opcode here, load fast and clear. What this is doing is it's basically blanking out this I variable, creating a separate scope for it, because this is the only variable that gets assigned inside of this comprehension here. So you can see here, I is the only target variable in here. So it basically creates a separate scope just by saving the current value of I and putting clearing it out. And then you'll see after the for has ended, so this is kind of the comprehension bit here. It's build list and then eventually store fast into x after the for loop has ended. You'll see that we do another store fast back into I. And this is basically restoring the value that was set before the list comprehension. Kind of clever, avoids needing to call a function and is way faster. It's, one stack operation instead of having to do a whole bunch of allocations and calling a function. So pretty neat little optimization. I didn't write down the benchmarks on this, but in theory it should make list comprehensions even faster than they already are, because they're already one of the fastest things you can do in Python. But pretty cool little optimization here. All right, cool. Let's go on to the next one. The next one is that the invalid escape sequences have been upgraded to a syntax warning. This is to signal that they will imminently become a syntax error in the future. For those that are not familiar, if you have a escape sequence, a backslash followed by a character that's not known to be an escape sequence, previously you got a deprecation warning. Now that's been upgraded to a syntax warning. The correct way to write that expression there is with a raw string here, or with the backslash escaped. Yeah, so this is commonly seen in regular expressions, and this has been a deprecation warning for quite a long time. If you're worried about catching this in your code, there are two tools that can help you out here. So let's say we had, t4.py, I think we're up to. Yeah. We have our invalid escape sequence here. If we run it with Python 3.12, you'll see that we get an error. If you install PyCodeStyle, which is included with Flake 8, PyCodeStyle has a special lint code for this, so you'll see you'll get W605. Definitely don't ignore this one because it's going to become a syntax error. These are a bit tedious to fix manually and very error prone to fix manually, so I made a tool, or I made part of my tool, PyUpgrade, handle this for you. So you'll see here, before we, cat t4.py, before we run this, we have our invalid escape sequence here. If we run PyUpgrade on t4.py, it's going to fix it automatically for us. It also handles all of the weird edge cases, so it knows when to double backslash it versus doing a raw string, and is very clever about that. So little self-plug here about PyUpgrade. All right, so that's most of the big things for 3.12. I wanted to go over some of the stuff that I was personally involved with, because yeah, I am a member of the Python community, and so I get to do cool stuff too. Oh yeah, here's the PyUpgrade stuff. PyUpgrade also does a whole bunch of other stuff, so I don't know if you somehow haven't seen it before, maybe check it out. The thing that people really like is the fstring rewriting, so probably the flagship feature, but was not the original intent. All right, so one of the things that I was involved with is I originally reported this as a security bug, but it was decided first not to be a security bug, and then it sort of was and sort of got backported in like a weird way to 3.11. But in theory, it is new in 3.12, and so I'm going to call it out in this video. But you could write out a syntax, a source file that looked very strange. Assume this is actually a null byte here and not the characters NUL. This looks like an assignment and then should be a syntax error and then a random like sort of string that's not terminated properly. But the way this was interpreted is the C code in Python did not interpret this properly. It interpreted this as a C string that ended here and then ignored the new line here and then joined this as a single string here and then executed this code. Basically, null bytes were mishandled inside of the parser, and there were all sorts of like weird things that you could do with this. So I proposed 3 changes here. One being that if the parser encounters a null byte, it should be a syntax error. Where are the other 2? Anyway, went back and forth. I taught Guido something. A lot of stuff happened here, but basically it was decided that this should be pushed out as soon as possible, and actually it was backported to 3.11 due to some other internal error inside of the C parser. But null bytes inside of source, now a syntax error. Previously, you could do some clever stuff with Latin 1 to force them to still be possible in there, but now it is a syntax error. I didn't do any of the change set for this, but I did report the bug, and that's some back and forth there. So that's kind of cool. Another one that I indirectly was involved with, which I'm really proud of, is Python is now using pre-commit. Pre-commit is the, they're not using pre-commit CI, which would be even cooler. But pre-commit is the linter and code formatter framework that I wrote. And so this is now running on every single commit of CPython, which is kind of cool. They're mostly just using it for YAML and whitespace checkers, so not too much is being used here yet, but they have added actually a Sphinx linter. I've not heard of this one before, so I'm not sure where this one comes from. Oh, this used to be, oh, yeah. So CPython used to have, CPython used to have its own RST linter, and it looks like this has been split out. So in a way, CPython has taken something, made it reusable for other people, and now it's also usable by pre-commit, which is pretty cool. But yeah, anyway, so sort of indirectly contributed to this, and I'm pretty happy about it. Okay, so that's kind of like the big things. Now we got a bunch of small rapid fire things to go over here. So we already talked about the setup tools one, so I get to skip that one. Next is cache property. This has been available since Python 3.8. However, it had a really annoying deficiency in that it had an undocumented lock that made it really slow to use, or slower than it needed to be. And it was locked per property instead of per instance, and so it wasn't actually that useful. But it also, made code slow. Anyway, it's been removed, so it's no longer in 3.12. So if you're holding out on using cache property from CPython because of this, now use it. Another one that's cool is unit test has gained one of the settings from PyTest, the durations property. I'm using PyFlakes here because it has a classic unit test case or test suite. Unit test discover PyFlakes. So normally the output looks like this, but you can add durations to this. Let's do 5 because otherwise we'll run out of screen. And what durations will do, I spelled it wrong, but it has prefix matching, so that's kind of neat. It'll show you the slowest tests. So if you want to go through your code base and try and find the slow tests and fix them, this is one way to go about doing that. So you can see here that the test read from standard in is one of our 5 slowest tests here. And you can, of course, expand that out to a larger number if you want to look at more tests. But if for some reason you're not using PyTest and you're stuck on unit test and you still want to find your slow tests, this now exists. Cool. PDB, the debugger. Show this. I'm just going to put a breakpoint in some of these functions. Let's do this one. Sure. Put a little breakpoint in here. Let's actually just run the test suite again. PDB gained some new features. Basically just one feature, which is that you can store variables that will stay throughout your session by putting a $sign in front of them. So you can say, maybe x equals 1, or maybe I imported, I don't have anything, right? Yeah, I don't have any modules available. I don't know. Let's say I imported token. I could say token equals token, and now I can reference the token module throughout the rest of my debugging session. Normally, and here I'll show you that, normally if you assign a variable and then you were to continue in a different debugging session, that variable just goes away. But these ones that I've assigned with $signs before are not available. Okay, maybe there's some special syntax for this, but I didn't read this too closely. I just assumed it would work. Oops. Yeah, so there's a way to assign them. I don't remember how it works. Whoops. I'll leave this one as an exercise to the viewer, but it's supposed to work. I just must not have paid attention to the docs, but yeah, so there's a way to access stored variables, and there's a way to access exceptions and other things. I believe exceptions is $_exception. I'm not actually in an except block here, so we won't see it, but we'll have to read the release notes again. Okay, that's changed the PDB. Oh boy, this is not okay. Anyway, we'll kill that. Next is itertools.batched. This is a new function in itertools which allows you to get a chunk of things. So let's say we had an iterable that's, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, this will be good enough to represent what I want. Import itertools. You can use batch to get chunks of things out. So let's say we wanted to iterate each of these in chunks of 3. You could do like for ABC in itertools.batched it3 and AC. And so you'll see that we get 3 chunks of this. Now you could previously do this with zip or iSlice or a couple other ways. There's some recipes online, but this is now in the standard library. It does have one unfortunate behavior, which is if you give it a number that's not divisible by the length of your iterable, instead of producing an error, which it can't really know up front because it's not a sequence, it's an iterable. Instead of producing an error up front, it will run through the loop until it gets to the end, and then it will crash. So, yeah, maybe not as useful as it could have been, but it kind of makes sense. But it's something definitely to look out for here. Let's see. The next thing is that the build of Python now supports the Linux perf profiler. I actually don't know much about perf, but a bunch of people are really excited about this. Apparently perf is really good for finding, performance issues, both from CPU and memory and other stuff, but I don't I don't know what I'm talking about. So just trust the people that are actually excited about this, that it's actually something cool, and not me, because I don't know. The last one I have on my notes is some improvements to error messages, and this has been happening for basically every Python version for a while. Pablo's been really involved with this, making error messages better. Basically, if you, let's see, I have four things written down here. So the first is, the first is if you access a standard lib module that's not imported, it will recommend you import it, which is kind of cool. Another one is missing self. This one is a little bit more tedious to write. Self x. Let's see, def init self x equals 1. So if we c.f, you'll see that this was meant to be self.x, and so the error message helps find that for you. If you accidentally do JavaScript imports, counter from collections, when it's actually from collections import counter, there's a new error message for that. And the last one is, if you have the wrong casing, actually just use counter, it will recommend the correct casing here. So lowercase counter, uppercase counter. Just a few small error message improvements, but always appreciated because error messages are great. Oh, this has been a long one. Anyway, I hope you enjoyed this video. If you made it to the end, bless. If you have additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.